Okay, we are now recording. So, welcome to everyone today. I'm glad that everyone that's here has the opportunity to attend, and perhaps some others will join as we go along. So this is going to be a webinar. So this is an activity that's related to a larger project, an international consortium of various shipping companies and research institutions called Wind Assisted Ship Propulsion. So the focus, of course, is no surprise, is on using wind assistance technologies in the shipping industry. So there is quite a lot of motivation currently to decarbonize shipping, to try and do anything that we can to mitigate the use of fuels, of hydrocarbon fuels. And of course, one possible methodology is to use wind assistance, because wind is there, it's essentially freely available, of course, not truly free because we have to pay to install the technology on the ships, but once it's there, you can use that wind to, of course, offset some of the fuel that you have to use in the ship. But there's certainly a lot of challenges that are present, both technical and financial. And so the focus of this webinar today is going to be both. So I myself, I'm Professor Joshua Lacey. I am I work here at KU Leuven in the Mechanical Engineering Department. And I'm just going to give you a brief introduction to our two speakers, and then I will turn it over to them, and I'll just briefly explain how we'll handle question and answers sessions. So our first speaker today is Gavin Allwright. So Gavin is the Secretary General of the International Windship Association, so it's IWSA. And basically this is a group of various wind propulsion companies and research institutions, academics, et cetera, that are all working to promote the implementation of wind propulsion in the commercial shipping industry. And so Gavin is going to give the first talk, which is largely going to be focused on some of basically the technical portfolio. What are the options we have available? And he's also going to discuss in the kind of larger context this WASP project. And then our second speaker is Orestes Skinas, Professor Orestes Skinas. So he is a founding partner of HHX Blue. And that's a firm that is involved in maritime fintech. He's also, in parallel, he has a position as a professor of shipping and ship finance at HSBA Hamburg School of Business Administration. And he is the head, or in 2010, he became the head of and founded the Maritime Business School, which is kind of combines all of these shipping related study programs at HSBA. And so Orestes is going to give the second talk, the second part of this webinar, which will largely be focused on the financial challenges that come along with these various wind-assisted technical solutions. So basically the way this will go is Gavin will give a presentation, and then there'll be a bit of time for questions after he finishes. And then Orestes will give his presentation with some time for questions after his presentation. And then we have a little bit of time at the end, about 15 minutes, where basically it's a free-for-all of sorts. The question session is open to both speakers. And of course, the audience, you're all muted, but so what I'll do is everyone can raise your hand or just type in the chat if you have a question, if you don't want to speak. And if you want to speak, of course, I'll unmute you to ask your question. Otherwise, you can just raise your hand and type in the chat, which the speakers can then engage and answer. So with that, I will give the floor to our first speaker, Gavin Allwright. Gavin, you feel free to take it away.
Okay, thanks very much, Josh. Yes, thank you for inviting me to come and talk. And it falls to me to give about a 10 to 15 minute introduction to the WASP project, which is a North Sea region EU part subsidized project. So the EU contributes about half of the total budget here. And I'll explain roughly what's happening there, the work that we're doing there, and some of the impact that we're looking at. And then I will, in the second part of the presentation, which I'll actually change presentations, will be a wider overview from the IWSA's perspective, and trying to place that WASP project into some context around the other technologies that are available as well. And also I'll just touch quickly on some of the latest news and projects coming through the pipeline, some of the drivers, barriers, and I'll also touch on the sort of market forecasts. So some of that will also be covered and touched on by Orestes as well later. But without further ado, let's crack on with the wind-assisted ship propulsion introduction. So the project, the key objectives of this project, which was set up in late 2019, was to install 5 wind propulsion systems onto 5 different vessels, have those operating for over a year, with sensors checking the performance, validating the savings that those systems afford to the vessels, but also taking a look at how we could identify the viable business cases around this as well, of those wind propulsion technologies, capture some of the best practice, and of course capturing the worst practice as well if there's mistakes or problems, things that need to be developed and need to be focused on. And also then that experience helps to facilitate a level playing field for wind propulsion technologies. Now, this is all taking place in a period where, of course, the shipping industry, the primary concern since the sulfur cap or IMO 2020 was implemented, is pretty much on decarbonisation, and it will be for the next 2 to 3 decades. So wind propulsion technology is one of those low-hanging fruits, and I'll talk about that a little bit more in the IWSA part of the presentation. But one of the issues around wind propulsion technology is there's still not enough demonstrator vessels. The North Sea, the North Sea and Baltic areas are primary candidates for using wind propulsion, windy routes, good distances, a lot of shipping. So it was deemed that this would be a very good area to test and showcase these technologies and see the viability of those. The partners of the project include 5 ship owners, naturally, also academic and research institutes. We have an NGO, the Green Transition Group in Denmark, IWSA, of course, HHX Blue, which you'll be hearing about later, looking at the finance and those business models as well. So, and the lead beneficiary is the Netherlands Maritime Technology Foundation, and they are coordinating all of these activities as we're going forward. The project cycle. So what in fact are we doing? And it follows a fairly standard project approach where we have the research going on, then actually putting the technologies or putting the systems onto vessels, trialing those, as I said, over a 12-month period. So we get data across the board in all different conditions. That can be then compared with the vessel's standard operation. And remember that these are retrofitted systems that are being put onto the vessels. Those are monitored, evaluated. Then that data, that raw data, is then validated. We can then demonstrate the efficacy of those systems, and then push and give that data out in a digestible manner to the market, and look at how the market can be adapted, so we can see more penetration of the market. Then an iterative process continuing. Then we'll be looking at that again, going back to the trials, maybe optimizing those, possibly in a second step of the project itself. Now on the right side, you'll see the 5 shipping lines and what systems they're actually looking at. So we've got 2 ventifoils that are being tested. One is a standard one, which you'll see a picture of in a moment, which is bolted to the vessel. It's foldable, so we don't have air draft problems. There are 2 flat rack ventifoils going on a vessel in the near future for Busan. Now those systems are actually on a movable rack. Now the ventifoil system is actually a system where you have quite a stubby wing on installed, with vents at the back of that wing. So as the air or the wind goes around the wing, it stalls, and there's a fan going up the center of the wing itself, which sucks in the boundary layer and creates the thrust or additional thrust to those systems. Then we have the scanned lines application, and that is a Flettner rotor installation, and you'll see there's another one for the Eco Flettner. Now the Flettner rotor system is a rotating cylinder where when the wind hits that cylinder, you get a difference in pressure created in the fore and the aft. And this uses the Magnus effect, which is very similar to the curve ball in baseball, where you get a whipping effect created by that. So that's how it generates thrust. And I'll talk a little bit more in detail about Flettner rotors in the later stage of the presentation. And the final one is another wing sail that's being developed by Econowind to go on a Tarsus ship. And that's a more standard wing that pretty much acts like an aircraft wing would. But because it's upright, that generates thrust. So moving on, and as I said, I'll come back to those technology issues in a little bit. Okay, so the ships and installations. This is pretty much an information slide for you to take away later, but this just gives you an idea of the spread of the vessels. The big different type vessel is the Scandlines ferry, which is in daily operation between Denmark and between Denmark and Germany. So the others are either general cargo or a mini bulker, and those have an advantage where they have quite a lot of deck space available. Although on the you also want to be able to move sometimes the system. So on the Boomsma ship, you actually have a flat rack movable system. Now the project structure itself is based pretty much on a standard structure platform. We have the project management, communication activities, which I do the lead, not just communication, but dissemination. Then we have work package 3, which is the engineering and wind propulsion technologies, led by KUL. Then we have the policy and viable business structures and operations of wind propulsion technologies and performance. And that's a lot of the testing there. Now this is a picture of the MV Anki, which is in operation and has been for the last 4 months with a ventifoil system. On the left hand side, you'll actually see the fan itself, which sucks in that boundary layer around the wing itself. Now, if you're interested to see, there's actually a time-lapse video of this on the WASP website, which if you've got about 30 seconds to watch about half an hour of operation, that's quite interesting to see the foils going up and down as well. And as I said, these are retractable. They lay back down on the vessel when not in operation, or if it's in loading, unloading, or in dock where you don't want to use them. Now, this is something I'll come back to in a little bit more detail. The power of the wind. What does wind propulsion deliver? Well, in the WASP project, we're talking about wind assist, which is a motor vessel with wind attached to it. So all of the savings, all of the numbers that are put out there are in comparison with a wind vessel, sorry, a motor vessel with no changes to its operational profile at all. So, for example, with the Scandlines ferry, they're estimating somewhere between a 4 to 5% saving. But again, that's a large vessel with one rotor installed, but she doesn't change her operations at all. So she's not routing to catch more wind. She's not slowing down to maybe increase the percentage of the wind. She's operating just as she always has done, but still getting 4 to 5% savings. Now, a lot of people that don't know shipping very well maybe say, well, that doesn't sound very much. Well, actually, that is quite a substantial amount of saving if you compare that to other systems or other, if you like, energy efficiency measures that are easily available. Those would likely, if you're polishing a propeller or you're improving your bow, you're liable to get increments of 1 or 2% savings in those. But wind propulsion technologies, we're looking at systems that can be implemented today. We're looking at a non-fuel propulsion system here. So there is no need for infrastructure. There's no need for production facilities. Once the installation is on the vessel, you're getting, as Josh rightly pointed out, it's not free energy, but marginally it's free energy. So once you've paid for your system, you're getting free energy delivered to the vessel at the point of use for the lifetime of that vessel, available around the world today. And that gives, with the decarbonisation of shipping, and that is an imperative, that is a very big thing that is being delivered today. And a lot of ship owners are looking, how can they make the changes today? And it's a challenging situation. If you're waiting for alternative fuels, you're probably looking at a decade out before those will be really available, and likely to be at quite a high cost, at least for the first decade of availability as well. Competitive advantage, advantageous. So this gives an opportunity for a ship owner to push ahead, to save fuel, which is pretty much your bottom line. So I'll let Orestes talk a little bit more about that. Now, this is a picture of the Scandlines on the MV Copenhagen, which is a hybrid vessel, a hybrid roll-on, roll-off ferry. And on the left side is actually the rotor being delivered. The base plate of that rotor was put in on the vessel in a standard sort of maintenance port call. Took a few days to weld the base plate in. The middle picture actually shows the installation of the rotor, and I believe it took 5 hours. So she is in operation pretty much all of the time. So this was done during the overnight stop. So in about 4 to 5 hours, that she had no downtime. And for a ferry company, that's extremely important. And this was done back in May. So she's already had 6 months of operations. So we're starting to get a few preliminary results from that. And those results, as I've just said, I'm not going to dwell on this, but pretty much we're looking at, we've got the predictions, we go through the trials, and then we will be validating those results and then looking how they will actually demonstrate that to the market. We've got 3 main indicators within the project, but there's a lot of external indicators as well. But within the project, we're looking to save fuel, obviously, the reduction in CO2, so it's around 3.1 times the amount of fuel saved is the amount of CO2 saved. And also, just looking at how much actual energy, rather than the fuel saving, how much energy was generated. But of course, there's a lot of other indicators and impacts out there where we have, we're talking to the market, we're talking to policymakers, and that's a much wider impact that actually we can decarbonize quite substantially, and I'll expand on that in a little while. We can decarbonize quite substantially with technology that is coming into the market today. And on that note, I will, oh, sorry, just very quickly on the bottom right-hand side, you'll see the mock-up of the next installation, which is the Boomsma Frisian C installation. And that's an installation that will be going on in about, I think, a couple of weeks' time. There's been some slight delays on that. We will also be looking at 2 installations in Q1 next year. So thank you for that. I'm just going to quickly exit this one and go on to my second PowerPoint. It's the quietest classroom I've ever taught to, so that's good. Okay, so now I'm going to talk about IWSA, or as I said, really kind of start to put the WASP project into the context of the wider developments of wind propulsion. Now I'll quickly introduce IWSA. We are a membership organization. We started in 2014 with 12 members. We have over 130 members now, and those include everything from technology providers, which there's over 40 of, project developers, researchers, academics, research institutions. We have 3 large shipping companies that are now members, 2 class societies that are associate members, and we have a wider network of experts, etc., which probably includes over 1,000 connected people in that network. Our main activities are pretty much through the development of a new industry segment. So the idea is to expand the market and educate the market. So grow the pie of that's available for wind propulsion systems, and in a little while I'll show you the size of that pie that's being projected. And we're also developing a hub system or a center of excellence system around the world as well. Now, we talked about the WASP project, and I quickly touched on some of the shipping challenges, and I'm sure we're going to hear a little bit more of these when Orestes is speaking. But as I mentioned before, you know, decarbonisation is pretty much the issue of the first half or the next 3 decades of the 21st century. And if we're aiming at that 1.5 degree target, or as near as possible, all ships designed and built today must be operating in a net zero emissions world at the end of their service life. So in the 2040s, pretty much all of the new ships that are coming into the fleet today will be in operation in the 2040s. And every single ton of carbon that comes out of the smokestack of a vessel will have to be paid for. So it doesn't have to be a zero emission ship, but it will be being paid for. Now, obviously we have the IMO initial strategy on greenhouse gas emissions. You know, it's set, the emissions are set to rise. And the levy discussion, which is right at the bottom there, is now starting to really pick up. We've had an industry proposal around $2 per ton of fuel for R&D. We've got the EU ETS system, the emissions trading system, which has voted, or the EU has voted to include shipping in that trading scheme from 2021/22. And that will be a roughly $90 per ton of fuel extra. And just recently, there was also a proposal given to the IMO from Trafigura, which is one of the largest charterers in the world. And that was actually talking about $250 to $300 per CO2 ton, up to $900 per ton. And that's from pretty much from one of the users or one of the customers of shipping. So there is going to be a bigger debate, and I'll you know, I'm sure Orestes will touch on some of this as well. Now, what we talked about with wind assist, pretty much the delivery of savings or the energy, you're looking at a roughly 5 to 20% from a retrofitted system onto a vessel. And those are the kind of parameters. 5–10% is likely on small vessels with small systems. If you've got a larger system or multiple systems on a vessel, you could likely get to that higher 20%. But please remember again that that is on without making any changes to your operational profile. So you're not slowing down, you're not changing route to get more wind. You are simply going from A to B, motoring through the ocean. Now, with optimization of those systems, we could be looking up to 30% as a retrofit. But there's also the issue around optimized new builds. So if you're bringing new builds into operation, you can optimize them as wind assist, or you can go over that barrier of 50% and actually have primary wind systems as well. And we're starting to see those coming in or being proposed for the market as well. And I'll talk about those in a little bit. Around the installation, again, I'm not going to get into details here because I'm not a finance kind of guy. There are some options around here. So it's kind of looking at wind as a service, or Orestes will be talking about pay as you save financing models. If you're looking at a primary sort of purchase ROI, the golden number is around $600 per ton of fuel. That's when the ROIs start to make sense commercially. They do actually make sense already, but the industry likes 3 years, 3 to 4 years. That's the area they're comfortable with. Just before the COVID lockdowns, we were hovering around $550 to $600 a ton. So things were starting to make sense there on the financial side. But I'm going to move on to the facilitation. This is another issue around wind propulsion. And while it isn't the specific focus of the WASP project, we're also looking at the ability to help reduce the costs and increase the speed where other secondary renewables can come in. So these are things like hydrogen, ammonia, batteries, etc. If you are reducing the amount that you require of energy, then you're actually reducing the cost of those systems. Potentially you're extending your range. You've also got a speed option, so you can power down and use the wind to maintain your speed, or you can actually use it to increase your speed. So, and it gives you some bunkering flexibility as well. So if you've got wind propulsion on board a vessel, at times you could be looking at 40–50% of the power, but it's averaged out around 5 to 10%. Well, that means that you can go on, possibly if you're on a long journey, you can actually go to the next bunkering option where the fuel is cheaper, or the alternative fuel is actually available. So there's some other impacts. You're also reducing the amount of storage that you may need for those alternative fuels. And the final one on this is predictability. And as we all know, not many people saw the COVID situation coming. That's tested the resilience of everybody. We don't know what the future holds. And wind propulsion actually locks in a percentage of your fuel savings for the future at a stable price, which is zero. Now, a lot of people ask me around the barriers, and I'm going to focus on the providers here. We do have some policy, there's some policy drivers, but there's also some policy barriers, and the EEDI is not a particularly good system to encourage the uptake of wind, and a couple of reasons for that. One is that it uses a world aggregated wind matrix, whereas the wind being delivered to a specific ship on a specific route is not judged. Also, it doesn't go to a very high wind level, so these actually reduce the impacts of wind in that analysis. Price, obviously, that's a big issue around price at the moment. We're on historic lows, and we have the split incentive in there as well, where the ship owner has to pay for the technology, but the charterer actually gets the benefit from saving of fuel because they're paying for it. But around the providers and the technology toolbox that we're talking about, I'm going to expand on this in a moment, but the R&D finance has been lacking in wind propulsion, partly because it's a non-commoditized energy form. So you can't trade your wind energy here, but you can trade your hydrogen, your ammonia. If you've got a hydrogen system, then for the next 30 years of that vessel, you're going to be selling units of hydrogen to that ship. When you put a wind system on board, it's a one-off. As we said before, it's pretty much a free energy source there. People and perception. Now, these two things actually really do affect the appreciation of the technology. One is we've seen quite a big change in the boardroom at the moment, where a lot of the newer board members that are coming in really get the environmental issue. It's not an issue around should we decarbonize. They very much want to say, how do we decarbonize? How do we do it effectively? How do we do it competitively? And that's a massive change. 5 years ago, it was very much, we don't want to talk about this. But perception is also a very critical thing. And when we're talking about technology, we're talking about a wind system is probably the most visible thing you can change on a ship. If you change the engine, nobody sees it. If you change, even if you put in a scrubber, okay, if you know what a scrubber looks like, you can see that change on the ship. But pretty much anything else that you do on a decarbonization pathway is unseen. But if you put a rig on a ship, a large rig, say a 30-meter Flettner rotor, everybody gets to see that. Now, 5-6 years ago, that was seen very much as a detrimental thing. Industry is a big industry, but it's quite a small family. So people didn't want to set themselves up to be to fail, possibly to be ridiculed in that way. So it wasn't seen. It was seen as quite a negative. These days, actually, since 2018 and that initial strategy, it's increasingly been seen as a green badge of honor, and it's a visible way to show that a shipping company is making advances in decarbonization. Now, around that, very quickly around that direct application of wind power, this is quite a provocative slide, and it's one of the reasons why I like to use it, is when you use wind directly, you are utilizing pretty much all of the wind all of the time. You don't have much energy loss. Of course, you will get some energy loss, but you don't get much energy loss. However, if you capture wind energy from a wind turbine, you're changing that into electricity, the transport, the conversion, the bunkering, the combustion, the propeller. You're actually losing a huge amount of energy through that process. Is a movable, dependable fuel, liquid or gas fuel, important? Of course it is. No wind ship or very few wind projects suggest that anything should be done to remove an engine. You need those engines most of the time, but it's an inefficient way to use energy until we develop and optimize that even further. So the use of wind energy is actually highly efficient. Now, the approach that we're using, as I've mentioned before, we're using a wave approach, which actually looks at wind, potentially 20 to 30% of the energy requirement for the ship is being delivered. But then we're looking at, if we adjust the activity of the vessel, the operational optimization, the voyage fleet management, weather routing can be substantially substantial improvement on a vessel anyway. But if you're weather routing to get wind maximization, then you're actually developing some pretty interesting changes. And we've got a lot of data now for weather routing. You've also got real-time satellite weather forecasting. You also have on the vessels, you have a weather station, which is actually giving you real-time weather, so you can adapt your system, your wind propulsion system to that. And also some projects are looking at the use of LiDAR, which actually can detect hundreds of meters out the gusts of wind that are coming in, and adjust and maximize or optimize the vessel, optimize the wind system through that. Speed reduction. Well, we hear a lot about slow steaming, but not in connection with wind assist or primary wind. And the interesting thing there is, as you reduce speed, you reduce fuel consumption at a higher rate than the speed that you're reducing at. But the interesting thing is you're also increasing the amount of power that would be deliverable from the wind. So if you're bringing a vessel down to 10, 11, 12 knots, say a bulker, that's absolutely the perfect speed for wind to deliver a substantial amount. If you're running a container ship at 20, 23 knots, 24 knots, you're not going to get as much contribution from the wind. It'll still contribute, but nothing as much as, say, bringing that down to, say, 15 or 16 knots, which is the very slow steaming or ultra slow steaming level. And there's other aspects as well, crew training, etc. So if you were delivering around 20% from those, that's possibly a conservative estimate. Then if you're looking at the vessel, the V of WAVE, vessel optimization, then we've got a whole raft of things: air lubrication, reduced energy, engine power, energy efficiency measures, but integrating wind propulsion into the energy management system, looking at the design and the size of vessels. All of these things we can do on a standard vessel, but we can also do them in combination with wind, and then you start to get some real savings. So if we add those three up, we're looking at, say, 60+% of the energy, or the energy can be delivered from that, or reduced in its the requirement, leaving around 40% or lower for the more expensive and longer lead time eco fuels coming in. And it is this hybrid approach that can really change the paradigm. Now, the technology toolbox, I did discuss these. I won't go into too much depth on each of these because each of the technology segments have probably, at least in rotors and in hard sail probably has 20 different technology approaches. But the hard sail technologies are coming, some of them from the racing fraternity, where they've been optimized over the last 20, 30 years. If anybody's watching the America's Cup, etc., a lot of people ask me, how can a yacht go, a racing yacht go 2-3 times the speed of the wind? As far as I'm concerned, that's magic. It's, they've really refined not just the systems, but the materials of those systems as well. The real challenge is the scaling up and the cost reduction that is required for those to be commercially viable. That is probably the really critical area at the moment. It's not necessarily the design of the systems, and there are many, many different designs of hard. So it's getting those costs down and the materials that you're going to be using, and making those robust enough for commercial application. One of the key things around hard sail is that it also has a surface which can be used for, say, solar panels on there, and there are a number of systems that look at that combination as well. Now, with kites, if anybody was looking at the shipping industry 10, 12 years ago, you'd probably seen quite a bit of attention on kites. Then it dampened down. For about 7 or 8 years, it was a first generation of kites that were used. Now these are coming back into, the interest is coming back in there, and the kites that you can have either a dynamic or a passive kite. A dynamic kite will actually be moving, say, in a figure of 8 or in an up and down motion to capture the air pocket that is, or the wind pocket that is in front of the vessel, and these pretty much tow the vessel. They're pulling the vessel. The interesting thing is there's a new system being developed by Airseas, which is a spin-off of Airbus, and Airbus has brought in their sort of aeronautical technology here, and they have a fully automated launch and retrieval system. but these are also computer operated, and they're not a cheap kit. They're very large, but one of the great advantages of a kite is that it's off deck, so you don't need deck space. So it's one of the systems that can be easily retrofitted, and it can be retrofitted to big container ships, which is a big issue because they don't want to sacrifice any deck space if they can avoid it. Now, the rotors I'm going to come on to in, I think it's the next slide or the next two slides, and I'll show you the progression of where the rotors have been coming in. These are probably they are the market leader at the moment, and by the end of this year or the beginning of next year, we'll have 9 vessels in operation, but I'll talk about that in a moment. But they are quite a robust system. They're now being tested on all different types of vessels. So there is one. Well, okay, I'll talk about which vessels they're on in a moment. But as I mentioned before, these use the Magnus effect on a spinning column, and a lot of people don't even recognize that these are rotor sails. A lot of people will see them spinning and think the wind is spinning them, and it's generating electricity. It's completely the other way around. A small motor spins the cylinder, and as the wind hits it, that creates the thrust through that pressure differential. Then we come on to the soft sail and dyno rigs. Now, the soft sail dyno rigs, I think we're probably most comfortable, and these are the clearest link to a lot of people's perception of what a sail or a sailing vessel should look like. It's furlable sails made from cloth, made from soft material, and actually there are quite a few projects out there in varying sizes. This one you can see is called the Ecoliner, which is a new build system using the dyno rig, and the dyno rigs are an updated version of the square riggers, and was developed in the 1960s by Pols in Hamburg, and has actually been tested in the field on a number of mega yachts, the Black Pearl and the Maltese Falcon. So they've already got about 10 years plus of operational data. Now the challenge is to bring those into the commercial field again. The suction wing I talked about earlier, that was actually developed originally by Jacques Cousteau's team back in the 1980s. And was installed on a number of research yachts, extensively tested. That's now being brought back in, and there's 2 companies working on very similar systems around this. And as I mentioned before, the fan sucks in the Vandrey layer around quite a chubby foil where the air stalls, and that creates additional thrust. But of course, it uses some electricity as well. Now, there are 2 other areas that are being developed. One is around turbines, which I think everyone's familiar with. Some are looking at turbines as an opportunity for direct propulsion, others a mix of direct propulsion and electricity generation. And the other one is a hull form design, where actually the hull itself becomes a wing, and the pressure differential on either side of the wing actually creates thrust, which is a very, very different way of approaching vessel design. This one is developed by a Norwegian company called Vinskip, and it's around about 60–70%. I think they're looking around 60% savings on a route down to from China to Brazil and back again. It's LNG powered, and the more headwinds you get, actually, the more thrust you get. Now, a lot of people then say, okay, that's all fabulous, Gavin, but what's the stage of development? Well, by the end of this year, actually, I think it's going to be 13, not 14, 13 large vessels with wind propulsion systems installed by the end of this year, along with 20 plus smaller vessels, which are mainly soft sail powered. By the end of 2022, that is likely, just from the pipeline that we know of, to rise to 47. That's without a single commercial, single commercial contract signed between now and then. and that's unlikely. So it's quite possibly going to be higher than that. And these will either be in commercial use or in commercial sea trialing. So quite a substantial number of demonstrators will be coming in, and 5 of those are from the WASP project itself. So you can see that actually a lot of people are looking at the WASP project as a testing ground, as a trial ground. Industry likes to have 3 reference points if possible with the technologies. With the rotors, that's already happening, but on different sizes of vessels, that's really important. The ventifoils and the wing sail increases those reference points. And I'm going to do this slide very quickly. This is a market forecast, a couple of links to the reports, one by the EU that looked at a maximum of up to 10,700 wind installations by 2030, mainly on bulkers and tankers because of the amount of deck space that's available. The UK government's Clean Maritime Plan has predicted around about a 40 to 45% penetration of the fleet by wind propulsion in the 2050s. So, you know, a really substantial market. And if you'll see that graphic there, which is a little bit hazy, the big green circle is alternative fuel production, between 8 and 11 billion per year. Wind propulsion is the second from the bottom, between 1.9 and 2.1 billion pounds per year. So around about that 20%, 15 to 20% of the total propulsion spend will be on wind propulsion technologies. Now, I mentioned I was going to talk about rotor development. I'm just checking my time. I've got about 5 minutes left. This is just highlighting how rotors have developed. And actually, it's quite an old technology. It was the first systems were developed in 1925. The Wall Street crash pretty much did it for any new technologies coming through in the later 1920s. But it did cause a big stir in shipping as a new, potentially revolutionary way to move a vessel. Fast forward to 2010, and we had the E-Ship 1, which was initially going to be the first of a series of vessels, but it was decided, for numerous reasons, which I won't go into now, that wasn't going to be the case, and they just ran the prototype. And she's been operating pretty much non-stop for over 10 years, or nearly 10 years. So I think they had a short period where the engines were actually a problem, not the rotors. Then we've had quite a bit of development through from that until 2014-15, where we had the second installation, which was on the north, the Borés Roro MV Estradon, with 2 rotors put in. That kick-started a number of other installations. As she started to be validated, interest grew, and then we had Maersk stepping in with 2 rotors on a 109,000 deadweight ton LR2 tanker being tested. Enemy Bulker, 64,000 deadweight ton, I think Handy Max, I'm not sure, with 4 rotors on her, and those are actually movable. They're on small trolleys that move up and down the vessel, so you can, as you can see, she is geared, so they need to get the rotors out of the way of the cranes. Then we had first ferry installation, which is on the Viking Grace operating in the Baltic. Second one is on the Scan lines operating from Copenhagen, from Denmark to Germany. And we've had some general cargo vessel as well, the Eco Fletner installation on the MV Fem Pollux. We now have in the top right-hand corner a couple more installations. One of those, the Roord Braren one, is within the WASP project, but we've also seen sea cargo coming up, and since the WASP project has been set up, they're looking for one of their vessels to have 2 tiltable rotors. So that will be the first installation with tiltable ones. Obviously, air draft can be an issue, especially for vessels operating close in or on coastal routes as well. Now, this is another busy slide, and this is general information that I'll let you take away. But I just wanted to show you that wind propulsion is gaining momentum. Some of these, so we've got the Ventafall and the rotor installations, some of those are within the WASP project, but the ones on the right side are either new builds, retrofitted systems, or new build systems. And the latest piece of news, I think it's the very latest piece of news, is in the bottom right-hand corner, where Cargill, which is probably the largest agricultural product mover, they have 600 vessels chartered at any one time in operation. They tied up with one of our members, Bar Technologies. They're looking to retrofit a first tanker, and then they're going to be bringing that onto bulkers. And from what I understand is they're interested to install across their fleet. So there's some very interesting projects that are coming through here. In the bottom left-hand corner, you'll see it's even up to a VLCC level, which is one of the largest types of vessel in the world. The Chinese have been testing 2 retractable wing sails on those vessels, and they've just ordered one vessel. They've just ordered a second one for 2022, I think, with 4 wing sails included. And at the top, in the top of the middle, you've got MOL, which have just made an announcement yesterday that they're also combining their wind propulsion system here, that will be on a new build in 2022 with a hydrogen production system on one of their vessels as well. So they're going to be testing that system to produce hydrogen at sea while they're under wind power. So you're creating the fuel for your auxiliary engines as well. So there's a lot of development that's going on, but WASP is certainly at the center of this as a really coordinated driver and validator for a lot of the data that's coming out. And this is one of my last slides. We've been talking about large vessels. There's also quite an active smaller vessel and traditional sail development group, if you like, that's going on. There's a lot of designs out there for new types of vessels. There's operations, sail cargo operations. We've had a launch of a new sail cargo vessel, and also still some areas that continue to use sail for traditional cargo. For example, in East Africa, you'll still see a lot of cargo being moved by sail there. We also have operations in fisheries, and there's, I think, around 10 smaller cruise vessels which are operating, sometimes using the wind propulsion, or sometimes just the wind propulsion, or the sails are there for decoration rather than really for much propulsive use. But they do prove the model as well. We have some builds and retrofits going on. There's one in Costa Rica on the left, which is a wood build. The one in the center is a project in Denmark, but is actually going to be operating a daily service across from Belgium to the UK. Hopefully, I think they're looking to start next summer. And the last one is, I think, Falls of the Clyde, which is an old oil tanker that was sail driven. And there's a really fascinating story around there. That's at the moment in Hawaii, and they're looking to bring that back to Scotland, retrofit her, and put it into operation as a sail cargo vessel. Projects and collaborations, just very quickly, I think these are linked. So in the PDF you'll be able to go to this. Obviously, the WASP project is there. WISP project, which is a joint industry project between ABS and Marin, is looking at a lot of these validation issues as well. Some of the EDI work, there's overlap between WASP and WISP, and there's some cooperation going on there. Looking at the regulatory perspectives as well as how to remove some of the barriers. And finally, IWSA is also developing a wind propulsion accelerator. And this is my final slide. All of these companies that have their logos here are all engaging with wind propulsion now, and a lot of them have come on board over the last 12 months since WASP set up. So I think WASP can take some of the credit, but you'll be looking around this slide seeing some very big players. Not all of them are installing systems. Some of them are testing or looking into them. For example, Total is doing a survey of all the wind propulsion systems for their LNG tankers. But each one of these is engaging with some form of the wind propulsion jigsaw, if you like. And a critical thing is that classification societies now have guidelines. All of them have guidelines either published or in the process that are being updated. So from a technological point of view and from a safety point of view, the guidelines are very clear now. We're not talking about something that is a peripheral sideline technology. It's becoming mainstream and being brought in there. And I just point out, for example, Wärtsilä has just signed an agreement, I think the second agreement with a wind propulsion provider to provide all of the maintenance service and follow-up sales issues as well. So as we can see, that provision of wind propulsion is starting to mature, and the technological or the technology issues around this are starting to be either mitigated or solved. So, and on that note, I would like to pass it back to Josh. Hope I was within my time limit. A little bit over.
It's okay. It's okay. No, very, very interesting presentation. I know I probably actually have a few questions of my own. However, I'd like to open it up to the audience first. I believe if everything's working correctly, you should have the option to unmute yourself. So maybe if there's questions from the audience, just use the raise hand function and I'll come find you and call on you. Otherwise, feel free to type in the chat as well if you have questions, and I'll check that also and direct those towards our speaker, Gavin. So if there's any questions, we have one straight away. Dionysus, go ahead.
Can you hear me?
Yes, very well.
Okay, one question that raised to me was whether a hard sail could generate propulsion power and also generate electricity in the hull of the ship, for example, with the machinery.
Mm-hmm. So you're talking about hard sail, as in a rigid sail, not a rotor or something like that.
Yes.
Yeah. So yes, I mean the hard sails can certainly generate electricity if you have a solar coating on them of some form. I'm not so sure about the generation of electricity. You were saying in the hull. Is that correct?
Yes. For example, I mean also generating thrust and with the aerodynamics, and also receiving the wind in such a way that they can create electricity. So two things in one sail, for example. Is it possible?
Yeah. Well, I'm assuming it's certainly possible to actually modify the wing itself to have some kind of generator, or a small turbine could be incorporated. I'm assuming, but there's certainly with any wind propulsion system, if you've got a primary wind vessel, quite often you get too much wind delivered to your system, so you have to spill that wind. You can't use it. So if the one way that you can use it is by slowing down your hull, so having turbines that pop out of the hull and that can be used to generate return electricity power into a battery system or whatever, or feathering your propellers. So that's one way to do it. But the actual generation of power from maybe from the interaction of the wing itself, I don't know of a system that's doing that. But hey, could be please take a look at that, because if it's possible to do, there may be a niche in there for you.
Okay, thank you very much.
Okay. Anybody else have any other questions? We've got probably time for one more quick one for Gavin before Orestes begins.
I'm sure I've answered everybody's question.
Well, I have one or two, but I'll probably
go
save
ahead.
one for the free for all at the end, I think.
Okay.
Okay, so if there's no other questions, then I will turn the floor over to Orestes.
Give me 1 sec. Yep. Can you see my presentation?
Absolutely, looks great.
Great, thank you. So I will try to give also a very interesting presentation, as Gavin, I usually fail to do so. Gavin is a little bit natural in giving presentations, but I would like to focus a little bit on the wider problems of greening and let's say the possible solutions that we have. And I will focus on the wind assisted propulsion. And I think that I might, let's say, complete some of the ideas and let's say concepts that Gavin presented before. So first of all, as I said, just feel free to distribute this presentation to your students. The motivation for this presentation is no other but Alice in Wonderland, because this is where I think that the whole industry is like Alice. We just got a pill and we are hallucinating or dreaming or whatever, but we have to understand that the industry is in turbulent times, and the solutions that are ahead of us are not, let's say, the trivial ones, are not, let's say, the solutions that we have used in the past. And we have to understand that we are really facing a new set of challenges. So I usually clarify this position by saying that there is an urgent need to decarbonize the economy. There is political and regulatory pressure. The last that I can say is, let's say, the United Nations resolutions on decarbonization of the economy, and you can see also the huge political interest that currently are let's say challenging and competing for this, how to achieve this goal. There is a huge lack of capital for new buildings and existing ships in the industry. And the main reason is that our industry, the shipping industry, is not attractive. Why? Because the interest, the yields that are, let's say, promised to the investors are, let's say, not sexy, are not attractive. And the last but not least, I think, is the Industry 4.0. This is a buzzword term for the new industrial revolution, and it is about the distortion of current business models. If you would like to, let's say, use methodological tools and, let's say, how science goes, let's say, or deals with these issues, you can easily go to the ancient Greeks. And it is the same question as it is, let's say, Alice. Heraclitus said that no man ever steps in the same river twice, for it's not the same river and he's not the same man. So this is exactly what we have here in this industry. We are not the same industry. We don't have the same conditions, and let's move on. These challenges, as described, raise many questions, and I would like to narrow them down to: how will greening of marine transport and operations attract financing? At what price and terms? And if existing models, business models, will survive? Are we talking about an evolution, or are we talking about a revolution? So allow me to talk about money, and allow me to talk, let's say, on the, let's say, possible ways to, let's say, attract this money and this capital to finance greening. One key point is also that as a topic is extremely wide, and especially for those who have an interest in this field, they have to understand the challenge and the facts, and they have also to set some boundaries. It is impossible, let's say, to green the whole industry. It's impossible to green, let's say, every technology or the whole, let's say, marine engineering and marine technology, but we have to focus on specific cases, and we have to win small battles before decarbonizing the whole industry. And last but not least, the wind-assisted technologies are also, they provide us a wonderful example of feasibility and viability, and let's say also let's say a roadmap to the way ahead for similar solutions. Allow me to focus a little bit on regulation, not because regulation is, let's say, my favorite subject, but it is regulation that determines for the time being the rules of the game. As you can see, greening is a complicated task, and some of you might say, okay, why shall we go green? Because of many reasons, including climate change, I can briefly say, but the whole procedure started in Kyoto in 1992. The governments decided that we have to reduce the carbon footprint of the economy, we have to decarbonize the economy, and the United Nations gave the order to all specialized agencies like the IMO, the International Maritime Organization, the regulating body of the industry, to deliver rules how to decarbonize marine operations. IMO.
Orestes, sorry, if you sorry to interrupt. I don't see your slides changing on my screen.
Excuse me. I thought that it is.
I think maybe they're not advancing. Oh, there we go.
Because yeah, can you see that?
Yeah, perfect, perfect.
I don't know what happened.
Yeah, sorry. Just wanted to make sure we could see the slides. No problem. Go, please.
Right now. Can you see that?
Yeah, I can see your slide 6. Yep.
Okay.
Okay.
So IMO delivered the MARPOL Annex 6 rules, and that means that we have mandatory compliance of all ships that fly the flag of member states of the IMO. That means 99.999 something of the total fleet, of the global fleet. Moreover, we have societal and political demand, and this is not just a trend. Especially in the northern part of Europe, most of the, let's say, civilian and civic groups are very sensitive when it comes to greening and air quality. And this is also translated in other European instruments, like the Clean Air for Europe policies, that horizontally, not only vertically, let's say that is one only industry, address the issue of the air quality. And the third point is, let's say, mortality, proven mortality. Some of you might say, oh, this is a moral issue. Some of you might say, no, this is a fiscal issue. This is public money, how to, let's say, deal with public health issues. But in a nutshell, the whole thing is mortality. Greening is about CO2. It's about carbon dioxide. Why should we bother with non-greenhouse gases like sulfur oxides and nitrogen oxide? Because it was the easy part. It was just the beginning. SOx and NOx are related to other problems, like SOx with the acid rain, an issue that we have dealt as a global society very efficiently back in the 70s. Nitrogen oxides, that is also very, let's say, pollutant and very, let's say, toxic as a pollutant. It is also a fairly simple way, let's say, fairly simple pollutant to address, also very toxic, as I said. And we have also other non-greenhouse pollutants, or let's say elements, like the black carbon, that is the particulate matter 2.5 micros. And as you can see from the recent MEPC, that is the Marine Environment Protection Committee of the IMO, this black carbon is also an element that is included in the greenhouse gas study and in the revision of the strategy. And that means that pretty soon we're going to have also rules on black carbon. And as I said, these non-greenhouse gases can, let's say, attract our interest because of mortality and because of the, let's say, harmful character they have. But on the other hand, because they can be translated in CO2 terms equivalent. Please keep this just for a moment aside. make a note, CO2 equivalent. This is, let's say, I think one of the Eldorados of the future. Do we have technological options available? The answer is yine, yes and no. By consuming less fuel oil, then we, let's say, emit less CO2. That is, let's say, what we do in engineering for the last 140 years with the advent of internal combustion engines. We try to consume less and provide the same work.
Sorry, Orestes,
yeah.
I still didn't see the slide change for some reason.
This
there
is
we go. Now
okay. I don't get it. I mean, there seems that there is an issue when I change the slide.
Huh.
Okay. Can you see these? Can you see my screen?
Yes, I can.
Okay. So we can have better engines, as I said, about that engines that emit less nitrogen oxides. We can have better fuels like LNG or desulfurized fuel oil for less sulfur oxide. But we don't have a solution that fits all. We don't have this. And this is, let's say, the big problem of the industry, because the industry has been, let's say, slipping technologically for many years long. We were just installing a diesel engine, whatever the size might be, and we were happy with that. So, I mean, we didn't have, let's say, a mix of technologies on board. We just had an engine. This was a main engine or auxiliary engine, but fundamentally it was a diesel engine of a kind. And as I said, we don't have the technology to address the whole problem, but we have the technologies to lessen that burden, like, let's say, the wind assist technologies that Gavin presented. Who is going to pay the bill? It depends. Owners, because they have the absolute obligation of providing a seaworthy vessel. A seaworthy vessel is the one that possesses practically all certificates that are issued by the competent authorities, blah, blah, blah. That means a vessel that has all the necessary certificates to sail and conduct voyages in international waters. And, of course, the society, through taxes, dues, levies, and other, let's say, financial schemes that will get money from one pocket and put money to the other pocket. And this is, let's say, very interesting as let's say, an issue, because we have to understand who is going to pay the bill at the end of the day. So, the regulatory part is not over yet. Why? Because I'm talking about a huge uncertainty. There is uncertainty in the market on the level of the greenhouse gases that we have to reduce. There is, let's say, the provision for the let's say, for 50% reduction by 2050 versus 2008 levels. We have new pollutants, like I said, the black carbon. We will have also methane in the future. And we have also new regulations like the energy efficiency existing ship, or let's say old regulations like the energy efficiency design index. All of these regulations that are fuzzy, not accurate, and let's say maybe not the right tools. We have biased political support, especially to alternative fuels. For those living in Europe, you can see that Europe is promoting heavily ammonia and ethanol as an alternative fuel. This is, let's say, extremely questionable as an option, as a technological, let's say, option, because there is, let's say, scarcity, or at least there is no availability worldwide. And there is myopic attitude, like the combined operational and technical measures that was promoted last week by the IMO. Let's say concepts like speed limits, or let's say technologies like the exhaust gas cleaning systems that result in higher consumption, and that results in higher CO2 levels, etc., etc. So all these myopic, let's say, measures, in most cases, they reflect interests and vested interests of states. Nevertheless, there are unexpected opportunities, like the market-based measures, the enriched energy mix. So we're going to have ships that are not going to consume only heavy fuel oil, as in the recent past. We're going to have an energy mix that is LNG, that can be low sulfur heavy fuel oil, it can be marine diesel oil, it can be wind, it can be whatever. we are talking about, let's say, opportunities in innovative complementary technology like the wind assisted propulsion. I think that we're going to have a new bright future in equipment financing and leasing structures. And last but not least, I think that we're going to have a bright future for digital means and technology, because without the digital backbone, we cannot control, we cannot validate, we cannot verify the achieved levels of decarbonization, and we cannot share benefits and gains to the involved actors. We are right now at the dilemma where we have the lesser of the two evils principle. We don't have clear limits and targets. There is no fair and objective accounting of all these benefits. We have watered down regulations, what I said before about myopic attitude, and we have the unknown parameter of carbon price and market-based measures, that is uncharted waters. Gavin said that the systems were designed for something like 20 to 30 euros per CO2 ton. Right now, there are estimations with 90 euros per ton. Transfigura and some big players, they even call for $600 and $900 per ton. All of these estimations reflect predominantly financial interests and technologies. In my view, we're going to have, the industry faces, let's say, two options, the dilemma. We have the EU ETS system, that is, let's say, an emission trading system that is currently in place in Europe for land-based industries like the cement industry, the chemical industry, and so on. This is an imperfect tool. It's not tested in international assets and trades. We had, let's say, some period where we have tested the ETS system for aviation. ICAO, the other body that regulates aviation in Canada, that is sitting in Canada, they had CORSIA, a system that is very similar to EU ETS. Due to, let's say, political intervention and COVID, for the last 2 years, we don't have any experience collected. But it is a tool that is in place for the land-based industries. It is not tested for international assets like the ships and trades, but it is, let's say, one option. And this is what we can see at the end of all these regulatory documents of the IMO. And the other option are regional rules. And if we have, let's say, regional rules, then we have the end of the freedom of the seas. Let's say the end of the rules that governed the post-war regime, where practically ships flying any flag could engage in international trades and voyages. In my view, an imperfect tool could be fixed, and digital technology is the key, because what we need is transparency. Shifting to the, let's say, to the next point, the financial conditions. This is, let's say, the map. What you can see here is, let's say, the red line. This is the cost of fuel. This is the cost of bunkering in the bunkering spot of Rotterdam, one of the 4 major bunkering spots that we have worldwide, while the green and the purple lines are the lines of the activity. So we have the Baltic Dry Index and the Clark Sea Index. So, of course, these are indexes, as you can see. So we consider, let's say, 2010 as, let's say, the first year, as the base year. But have a look here. Have a look here. We have more or less the freight market conditions as in, let's say, in the past, as in 2010, even before, while we have, let's say, double the price of fuels. That means that the margins the owners and operators get out of the operation of ships is deteriorating. Of course, some of you might say, come on, some years ago it was 3.5, while here you had, let's say, a market of 1 indexed. And here we have a better, let's say, conditions. Yes, true. But as you can see, the cost of energy is continuously higher than the cost, than the revenues level. This these conditions are also reflected here. What you can see here with the purple line is the growth of the world fleet, while with this red line, what you can see is the top 40 banks, the top 40 lenders worldwide index. So if we go back in 2008 as base year, you can see that the gap between financing need and supply of financing is continuously growing. We have 67 units base of gap. This is huge. That means that something is wrong here. That means that if the big, let's say, lenders are not stepping in this growing market, there is something that is worrying. And what is worrying? It is, as you can see in other graphs, that these banks are leaving shipping not only because of the diminishing margins of the industry, but because of own banking regulatory rules, something that has nothing to do with shipping. So if you consider, if you just see here, let's say the lending portfolio, the exposure that was 450 billions in 2008, and right now you have less than 300 billions. In a market where you have, let's say, a value of around 1.2 trillion, so these top 40 banks were financing almost 45% of the total industry. These guys are retreating, and this is reflected also here, where you can see Europe. This is the blue area here. You can see the US banks here, and you can see also the Asian banks. That if you can see here, the total available lending is decreasing, and it's decreasing substantially. So European banks retreat at a rate of, let's say, minus, let's say, 7.1%, while the US banks and Asians try to cover the gap, but they don't have the capacity or the interest or the appetite. Having a look also closer at Europe, what you can see, the German portfolio that had around 155 billions exposure in 2010 is right now less than 40, and I think that the goal will be to be less than 30. So having a look at, let's say, the significance of shipping for banks, then these news are worrying, because what you also can see is that the average margin, that is, let's say, the cost of money, okay, this cost of money has increased from 200 basis points, that is LIBOR, that is, let's say, the base interest that banks pay in London, plus 200 units, let's say 2%. Right now you have, let's say, more than 250, 300, and this is, let's say, the average. And at the same time, the tenure, the duration of the loan, that used to be 8 years, 7.5 to 8, right now it's less than 5.5. I can tell you that the usual terms are maximum 5 years, LIBOR plus minus 400 units. That means that for most companies, the capital is becoming more expensive. And that means for every, let's say, million borrowed in the past, where you had to estimate around $400 to $500, right now you have $650 to $700, let's say, burden per million. And this deteriorates more and more and more the margin that is available for the owners and operators. In few words, good terms will come only from a good employment security, but that means big solid borrowers have this an advantage. That is, let's say, companies like Cargill or Transfigura. I mean, I'm just naming these companies because Gavin's mentioned these companies, and these companies, let's say, can drive, let's say, the decarbonization, and can, let's say, secure the employment that is necessary in order to secure good terms of financing. Industry 4.0. I said about this, but I think that all of you understand more than I do in this field. What we do right now is just an effect, an impact of Industry 4.0. I'm talking about interconnection, I'm talking about Internet of Things, industrial Internet of Things, that where we have also special interest for marine and maritime applications. We have Internet of Persons. We are talking about transparency, technical assistance, decentralized decisions. We are talking about a completely new set of technological options that expand the current concepts of liability, of control, and of, let's say, of management. Of course, we understand that there are challenges like security, lack of capital for, let's say, this transition, issues that relate to the employment of people. How many people do we employ as industry? How many mariners do we need? What is the, let's say, the privacy of these employees? Let's say, do this, let's say, employees have a private sphere, or let's say the company can, or let's say the enterprise, the employer, can have access also to private data, preferences, etc., etc. But at the end of the day, we realize also the benefits that we get in terms of optimization, customization, and transparency through all these, let's say, vast components and applications like mobile devices, 3D printing, sensors, smart sensors, whatever. I mean, the components and the applications are numerous. And what is, let's say, the name of the game is interconnectivity and distribution of information. But what may worry, as Alfred Newman of MAD says, why should we worry as an industry? We should be worried because the logistics and international trade are impacted, they are changing. The whole, our identity is changing. Think of it, I mean, we are talking about digital citizens. I'm not talking about a German or a Greek or whatever citizen. I'm talking about a citizenship that has a digital, let's say, footprint, digital attributes, and you can work and live wherever you like, but at the same time, you can be, let's say, an employee and taxpayer of another state. That means that it changed also our sense of privacy and our notion of ownership, which is very important. Please keep this aside also as a note, the notion of ownership. That is, I mean, we are moving towards an era where we're going to have coexistence between technology and humans. And this is the reason why I should care. Because Industry 4.0 impacts marine operations, data, sensors, automated ships, green financial schemes. Generally, all innovation is based on these principles, components, and application of Industry 4.0. And every improvement, every challenge of Industry 4.0 will be reflected in the technology portfolio of shipping in an unprecedented pace. Some years it was very difficult to shift, let's say, from the steam engines to the diesel engines because of the, let's say, resistance to change of the system, of the people operating, let's say, these engines. Right now, all these changes will be faster, swifter, and in some cases, smoother. How can we quantify the problem? Who is going to pay the ferryman? Who has to, I mean, how can we cross the bridge of death? Are green ships more expensive than conventional ones? Yes, absolutely, because innovation and technology has a price. At the same time, we might have also better quality. That means of equipment, of fuels, and all of this comes also with a price. Is the market willing to pay a premium for the greener services? No such a sign yet. We don't have any clear freight premium, let's say, for green shipping. Generally, what we have a younger fleet. We have a fleet that is operated by corporate schemes, not, let's say, small companies based on SPVs, special purpose vehicles. We have, let's say, green policies of users, let's say, like Transfigura or Cargill, they have green policies. So your ship, Mr. Ship owner, should not only be efficient in terms of cost, it should be also efficient in terms of greening and carbon footprint. So this is, let's say, this mix of younger fleet and corporate governance, etc., increase a bias towards a green ship. However, this is not, let's say, purely reflected in the financial schemes. Some of you might say, yes, there is a company XYZ that pays a premium or they have an interest. I don't disagree, but this is just the exception of the general rule that it is, let's say, difficult to generalize. How can we make, let's say, the choice between a conventional ship and a green ship indifferent? And the only way we can do that is by equalizing the cost of both ships. So considering that the operating expenses of both ships are the same, what we can do is we can lower the cost of capital. That means we have to somehow lessen the capital expenses for the green ship. That means that we have to, let's say, find cheaper finance, or by lowering the voyage expenses. Let's say these are port use, fuel expenses, etc., for the greener ship. And this is, let's say, a huge discussion, especially when it comes to the voyage expenses, because alternative fuels, for the time being, they might have an attractive price, but this is not necessarily guaranteed for the future. I will come to this point. First, can we lower the cost of capital? Absolutely, yes. That's nothing new. China, Korea, Japan, they do that by offering special financial terms to every ship that is built there, either by, let's say, subvending or providing subsidies to the yards in order to lower the price, or they provide very attractive financial terms like huge very long grace periods, or even a subsidy over the interest. Generally, the bigger the company, the better the securities they can provide, the lower the cost of capital. But in all these schemes, the state takes over a cost. So when China or Japan or Korea provide a subsidy or, let's say, an attractive financial scheme, and nothing against these countries, I think that they have a very smart policy and very smart people in charge generally. The state undertakes part of the cost. Of course, the benefit for the state might be higher in this case, but the state is undertaking part of a private project, of the cost of the private project. In other cases, where we have, let's say, export schemes, like in the case of Germany, or let's say Holland or Norway, they have all these export credit facilities and export credit institutions. That means that we, the taxpayers in Europe, are paying for this cost. So when, for example, the German export credits, let's say export credit facility bank, the KfW, is providing a loan with, let's say, interest lower than the market, then this difference is paid by me as a taxpayer in Germany. Because the other way would be, let's say, Germany to put this money in another, let's say, investment in another field and enjoy a higher interest, a higher return. So the state is usually taking part of this cost. And besides the cost of fuel, as I said, for the voyage expenses, I would like to focus on the cost of ports, because many people claim, okay, let's have a port competition. Let's say Singapore might give incentives, or Hamburg might give incentives, or Port XY might give incentives. I would be very careful, because by having, let's say, local regional rules, then we might discriminate ships. And that means that some ships are not going to be technically fit to call specific regions. And that is, as I said, the end of the freedom of the seas. But at the same time, when we lower the port use, and think of it, when the port is willing to get less revenues just to, let's say, welcome a green ship, then this loss of revenues is translated as a loss of income for the state, because usually the ports belong to the state. I'm not talking about the terminals, I'm talking about the ports. So if we have, let's say, this luxury, and think of it, the state is getting less, let's say, revenues in order to support green shipping, this is a very interesting national policy. However, it comes with a price, and at the end, it might result in a patchwork of rules, local rules, and that could also result in an unlevel playing field, something that most owners hate to consider as an option, reasonably. If you do the calculations, because I would like to focus here on the price of alternative fuels, I have done some calculation for a 75,000 tons bulker, a very common ship, a Panamax, and we can definitely discuss the terms. As you can see, we have a low sulfur heavy fuel oil ship, we have a marine diesel oil fuel ship. The engines of both these configurations can easily consume either low sulfur or marine diesel oil fuel. There is a slight difference here because of the higher price of the marine diesel oil, usually vis-a-vis the low sulfur heavy fuel oil. We have a diesel engine that is dual fueled. That means that we have LNG and a pilot fuel that is usually marine diesel oil. And LNG currently is, let's say, has a lower price than low sulfur heavy fuel or marine diesel oil in terms of metric ton equivalent. And we have, let's say, a conventional ship that consumes low sulfur heavy fuel oil and is equipped also with wind assisted technologies. In this calculation, in this very simple, let's say, indexed way of comparing, let's say, the engines and the configurations, and having as one, let's say, the conventional ship, you can see here that the dual fuel engine, let's say LNG plus the pilot fuel, might result into, let's say, less US dollars per ton mile. That means that the transport is cheaper. However, have a look here in the sensitivity analysis when you have price differentials. So if we have, let's say, this price here for LNG, if we just say that the fuel price differential is 12%, that means that LNG is less than, let's say, cost less than 12% than the conventional fuels. See what happens if we have, let's say, 5%, if we have 0 or 5 or 10%. I don't see any reason why LNG should be always cheaper than heavy fuel oil. Maybe it is a lesson that we got from out of the energy crisis in the 70s. Because back in the 70s, at the beginning of the 70s, no one ever thought that OPEC would increase the price. But within one night, the unit price of energy was multiplied by 7. So when most Americans and Europeans, let's say, went to bed, it was, I don't know, $1 per something. And when they, let's say, woke up in the morning, it was $7 for the same unit. So as you can see, these alternative fuels, the efficiency of alternative fuels, and especially the financial attractiveness of the solution depends heavily on the price. I don't see anyone from these guys promoting alternative fuels highlighting the price issue. Just open any, let's say, report of any big manufacturer giving you, let's say, a fair or, let's say, a diagram or indication or whatever of the price of alternative fuels. And this is, I think, a huge issue. Besides all other issues like infrastructure, aftermarket, for second-hand ships, etc., etc. On the other hand, if you consider the capital expenses, let's say, the price, the acquisition price of a conventional, let's say, ship and of a dual fuel ship, let's say LNG fuel ship, that is circa 10% more expensive than the conventional one. And let's say a conventional one equipped with wind assist technologies, if you can see here the indexed result, you can see that the combination of conventional technology and wind assist technology might be better than, let's say, any alternative fuel technology installed on board ships. So we have to be very careful. And I think that it is very difficult to lower the capital expenses unless the company is big enough or they have, let's say, a set of securities that they can provide. But when it comes to lowering the voyage expenses, we have to be very, very careful, especially when we discuss about alternative fuels. I can tell you from experience that in many cases we don't have, let's say, a feasible solution. Seems like we try to divide by zero. So the current dilemma, what we face right now, is that we need new financial tools and we need new business models that stretch over the conventional risk-yield dipole. This risk-yield relation should be redefined. And that means that we need, let's say, to consider and to examine models, business models for the new economy, let's say the shared economy, the circular economy, the green economy that emerges. We have to forget, let's say, the past. So I'm not going to, let's say, focus on the wind assist technologies. Gavin gave a wonderful presentation. What I usually steal from the presentation of Gavin is this slide of Lloyd Register that I consider as very interesting, where you can see all these benefits of the wind assist technologies. But I like it because it says here that these technologies should be proven and validated by 2030. And I would like to say even sooner. So the technologies are here. Gavin presented all of them. Once again, the only thing that I would like to highlight is that prepare yourself for a different future. For those who think, for example, that the caper of, let's say, 170,000 tons is not replaceable by two Panamaxes of 75,000 tons, this perception is wrong, because the energy gains, let's say the unit transport gains that we have by having a bigger ship might be diluted from technology. Two Panamax of the future might require less people on board because of automation, because of, let's say, new digital technologies. They might be, let's say, more attractive than a huge big ship, also in terms of insurance. So I think that we have to recalculate all these cost elements, and we have to reconsider shipping not as a cost leadership, a unique cost leadership, let's say, strategical option, but we might think of, let's say, more aspects, more dimensions in our financial issues. So the pictures are here. I just wanted you to see that these ships exist. And this is also what we right now consider in all these options when discussing new projects. Gavin said about the pay-as-you-save, and this is a very simple concept. Right now, when a ship owner is buying a technology, for example, assume that I am the ship owner of this beauty, and I would like to install Flettner rotors, for example, then I have the risk of the selection of technology, which Flettner rotor, which technology, which automation package. Should I consider kites or Flettners? It could be another, let's say, technical dilemma. So the owner faces the risk of selection. The owner faces the risk of the purchase, the risk of installation, the risk of operation, and of course the owner is getting the sole benefit out of the operation of this technology. Usually the technology provider is getting, let's say, his money, and he's out of the picture. The pay-as-you-save model is a little bit different. So it is about sharing benefits and risks among all actors. So in reality, what is the model? What is this financial, let's say, constellation? The owner gives to the selected technology provider only an amount of money, let's say 20-25% as an advance payment, and the rest of the financial obligation comes or is derived out of the benefit and gains. Gains, for example, by lowering the consumption of the ship, or even by measuring the attractiveness of the ship in the time charter market or in relevant markets, and of course from the carbon prices, because the carbon price and the market-based measures imply that carbon has a price. So when you have, let's say, lessen the need for carbon allowances, or you have carbon allowances that you can sell, then you have a tangible gain that could also be reflected in your books and in your pockets. The beauty of this pay-as-you-save system is its simplicity, and it is also its ability, its inherent ability to be expanded. And of course, it is a model that is malleable in the sense that you can draft the terms in a way where you can find this sweet point. So, for example, in this simple example for Vendifoil sales, as you can see, the ship is having a negative NPV till the 6th year, and after the 6th year of operation of these Vendifoil sales, in this example, and please do not generalize, just see here indicative examples, then the NPV is growing, is picking up. I assume, I mean, if we run the model for, let's say, more than 10 years, let's say 11, 12 years, etc., the NPV will be higher. That means that the decision at this, let's say, base year will be, let's say, higher after, let's say, 12 years than in 10 years. In this example, we have a financier. So the technology provider, let's say the guy who is producing the Flettner rotors, has practically sold his rights to a financier, let's say to a financial house. Why? Because this company might, let's say, sell at a lower price, and these guys might buy at a lower price, but after a point, these guys here, the financier, might enjoy all the benefits that come from the reduction of consumption and from the and also from the carbon price. The sensitivity analysis can be further, let's say, produce results like results over the utilization scenarios. For example, how often are these Vendifoil sales used, or over the sharing ratio scenarios. For example, you have 50-50 schemes or 60-40 schemes or whatever. So as I said, it is relatively easy to derive sensitivity analysis and results. Of course, you have the fuel price scenarios. So generally, the higher the price of fuel, then the higher the benefit that both the owners and financiers enjoy. Consider, let's say, the current prices. Today we had $47 per barrel, and that means that we have around $350 per ton. That is without the supply cost. So with the supply cost, we have, let's say, a price of around 370 to 420. So we are somewhere here. Even at this low, I mean, at today with the low, let's say, levels of fuel oil, then we still have a positive NPV for, let's say, both parties involved for this example, for these, let's say, figures. And carbon pricing the same, etc., etc. So besides the pay-as-you-save, another field where we at HHX, we explore and experiment, and we think that we're gonna be active pretty soon, is, let's say, tokenized finance with cryptos. I think that most of the students are already buying and selling cryptocurrencies. I'm not going to get into the technology and the options. What I'm going to say is that by using tokenized finance, we increase the liquidity of the investment. And that means that we bring transparency and we create an aftermarket where the investors can easily exchange tokens or sell and buy tokens or cryptocurrency or whatever in order to enter or leave in a project. So currently, what we have an investor who is providing money to a fund, and the fund is providing money to an SPV, a special purpose vehicle company, that is owning, let's say, a second-hand ship or any ship. In this case, what you have a flow of money, and you have, let's say, money back. few money, or let's say a lot of money, or let's say good money, or whatever, this is, let's say, irrelevant for the time being. However, if you could, let's say, tokenize part of this solution here, part of this relationship here, you could get the benefit of the project times the benefit of the increase of the internal value of the token or of the demand of the cryptocurrencies. So you multiply, you magnify the yields that you get from an investment. At the same time, it is bankable, it is transparent, and brings liquidity that everybody would like to have. I said before that we have to expand the risk yield dipole. That means that the same investor here can provide to the fund money, let's say capital, and this fund can allocate the money of the investor to different projects in a different way. So instead of having, let's say, the sum from the investor invested in a single ship, then the tokenized financing enables a better allocation of the initial money of the investors to different projects and to different characters. Some of you might say, okay, this is just pure finance. I can say no, because besides, let's say, the financial terms and conditions, you also might have green terms and conditions, let's say decarbonization by XYZ or employment of technologies XYZ. So there are many green criteria that you can include in your financial scheme. And that results, of course, in an elimination of all these intermediaries. So in this, let's say, tokenized solution, you have only one, let's say, intermediary, and this is, let's say, the financial house that provides the blockchain solution. While in conventional financing, you have everybody. You have investment bankers, you have custodians, you have the stock exchange, you have client accountants, and an army of people working and living out of this relationship. So closing remarks, I'll try to be brief once, if possible, because the topic is huge. Greening is necessary. Shipping must cope with the change. Regulation is uncertain, and uncertainty results in discouraging investment. Regional against global measures are very dangerous because they dismantle the fundamental freedom of the seas. But the market-based measures, in my view, it is a positive development because they also financialize the industry, and that means that the green criteria, the green attributes of any project can get into the financial term sheets. Banks are retreating from ship finance due to many reasons, huge losses in the past. That is a very relevant information, but irrelevant for greening. We had abuse of the financial models and tax incentives in the past. That's nothing new. We have lack of attractive returns, which is a big issue, a huge issue right now in the market. We have very few big players, and I remind you that if we have, let's say, high concentration in the market, then we lose the wonderful conditions that we have in the shipping industry, this perfect market conditions where you can become a ship owner. If you have the money, you can leave the market whenever you want. You share the same information, and your product, let's say your service, is easy to be replaced. This is, let's say, the beauty of shipping, and there is no other industry like shipping. That's why it is really such a competitive industry. We have another issue from the big banks that I did not highlight, that is the interest of the big banks on new buildings, and that comes from the regulatory requirements of compliance of the financial institutions. That has nothing to do with shipping, but a banking financial compliance. And we have also other markets like the second-hand markets. We have greening markets, etc., that are not served currently by the banks. The Industry 4.0, as I said, changed everything because data-driven decision-making emerges. We have transparency transactions, and we have interconnectivity, interoperability, automation, and all these aspects that allow me not to discuss further. But the one point that I would like to highlight is that greening depends on data. No data, no verification of the results, no transparent financial schemes, no trust in the relationship. There is no one solution fits all option for decarbonization. As I said, I'm very critical against alternative fuels when it comes to price, infrastructure, and other requirements. Wind assist technologies can serve especially short and mid-term decarbonization goals. Definitely, there is no doubt about it. And there is no financial capacity or appetite unless we shift to the 21st century, let's say, business models. So it is impossible to deal with a 21st century problem, and this is, let's say, the decarbonization, with the mid-20th century financial tools, let's say, the conventional financing schemes that we had in the past. PACE, tokenization, and numerous other methods. I'm just advertising the ones that we have in our house, in HHX, could be possible solutions. I think that many people work on this subject and expect, let's say, more financial engineering and innovation in this field. And as I said, the last but very important point is that everything boils down to data management, data control, data ownership. This is the new maritime game. Data is the new gold. I would not be surprised if, let's say, financial models of the future will be based on the acquisition, ownership, and distribution of data, and not on the, let's say, ship per se as collateral. Data are the game changer for greening and financial returns. Without data, we cannot design green solutions, and we cannot, let's say, employ financial models. So thank you very much. I hope I was within the time. Okay, Josh. And
Yeah,
some references from my side and some other contributions from other, let's say, researchers. Please, it's not an advertisement of our work. It is just, let's say, some recommendations. Especially for students, I'm open to discuss all sorts of, let's say, literature, sources, etc., etc. Yep.
That's excellent. Thank you, Orestes. Very, very interesting presentation. So yeah, again, I probably have some few questions I'll put forward. But first, I will turn it over to the audience. So all of you should have the capability to unmute. So feel free to just raise your hand and then ask your question. Okay, so looks like we have a question from Martina. Go ahead.
Hello, can you hear me?
Yes, hear you just fine.
Thank you very much. It was an amazing lecture, and I think I learned a lot. And now I have a question that you might not have the answer, but I have, I can't stop myself from making the question. If we had to carry out the tokenization for ports or windship operations, is there something that you would recommend? Something like some specific strategy or operational method, sequential method, something that you could help me imagine it better, please?
Are we talking about ships or about ports? Because these are two different things, two different assets.
Very right. Yes, you're correct. Let's talk about
tokenized financial means will be part of the future, because as I said, they increase the liquidity, and then they can also attract different kinds of investors. So the beauty of tokens is that at the beginning you may have, let's say, very sophisticated investors who understand the business, attracted to a project, into a class asset. It could be, let's say, a ship type or whatever. And then after a point, let's say, these investors, they might change strategy and they can sell, let's say, the project and the returns, the expected returns, to anybody else in a very simple and transparent transaction. Theoretically, one can do also this in a secondary market today, but it's very difficult to happen, and it's regulatory also a nightmare. So to cut a very long story short, I think that yes, tokenized funding and tokenized funds is part of the solution of the future. This is one of the reasons why we strategically invest time and effort in this business. And with, as I said, with all the data that you can get from the greening system, wind assisted propulsion, let's say measurements that you get from the engine, whatever, you can design financial models and you can sell these models, this financial engineering that is necessary for promoting technological evolution as well. So I think that tokens is part of the game, part of the future.
So for example, oh, I'm sorry, but I don't want to monopolize. But so for example, if we would like to implement the same plan for bigger, like for at the port authority level, this would be a political stance, right?
It is an issue of who owns the asset, and usually we have to clarify who is getting the benefits, who is sharing the benefit, and yeah, I mean,
Okay.
ports
Yeah.
are subject to the national law, while ships are usually subject to national and international laws. Therefore, it is, let's say, it is a class of assets that is, let's say, very well understood by international players. Ports are national interest, local risk. It's like buying the risk of Piraeus or the risk of Rotterdam. It is connected to the state.
Okay.
Thank you.
Yeah, thanks for that. The question. Any other questions from the audience? In fact, feel free to involve either Gavin or Orestes, either of our speakers. Okay, we actually have something in the chat. Let's see. Are there any early percent indications on the life cycle costs versus acquisition costs for the various wind propulsion technologies? That question might be directed a little bit more towards Gavin.
Yes, yeah, I'm just looking at that. Are there early percentage indications on the life cycle costs versus acquisition costs? So we're talking about all of the material costs, embedded energy, etc. Am I getting that correct?
I would
Okay.
bet you could mention.
Centrally, we're not or we're not focused on this work at present. However, there are a number of our members, or quite a few of our members, that are doing life cycle analysis of their systems, and that's more advanced in most of the more advanced projects. We haven't brought those together centrally yet because, of course, everything in an innovation space is kind of kept quite close to their chest at these early competitive stages. So they are using that within their sales pitch, though. But from my understanding, I'll just give you an example. One of the rotor providers I was asking them about the embedded energy in the rotor system, the percentage or the return on that, and they were saying it was something like about 3 months of operation would return the amount of CO2 that was expended in the actual production and installation of the rotor system. Relating that to the acquisition cost, that's probably more in Orestes's remit, but that gives you, I think that gives you an idea that it is under consideration. It is a concern. Interestingly, very little of this is done on for example, internal combustion engines. It's very difficult to get the carbon footprint of the production of an internal combustion engine as well. So, but yes, so work is being done. I'm sorry, I can't give you the percentage, but if you're interested and you're doing research in this area, I can certainly introduce you to a number of our members that are working on this and quite advanced.
Josh, if I may jump into here,
Of course.
I think that what Gavin said from the very beginning, it is quite interesting because most of the ships right now, most of the cost elements that we have right now, it is about retrofits. So we don't have so many new builds. And once we're going to have, let's say, the hull, the propulsion system, I mean, if we're going to have, let's say, the let's say, experience gained in the new building, hull, propulsion system, propeller, wind assist technologies, all of them in the design at the design stage as evaluated, then we can see also what is the actual cost of, let's say, the wind assist technology that has to be installed, and also the savings. So, I mean, besides, let's say, the cost of the wind assist technologies, whether rotors or kites, whatever, we're going to have also a smaller engine, and this smaller engine comes with a price. So it's quite difficult to say that for the moment because we don't have this data. I think that this data will be available once we have at least 100 new builds. Mm-hmm.
Yeah, and I think that point that you make there, Orestes, about the the issue. Often the market is looking at today's price. It's always going to be looking at the next unit to be sold or to be bought. But really, the economies of scale start to kick in when you have around the 100 units or the 200 units of a system being brought in. Then the cost of those systems starts to actually drop quite dramatically as well. So any comparison with the acquisition cost and the life cycle cost as well, you've got to work out which unit you're actually looking at.
And Josh, I think that we discussed that over the phone last time. Our friends and colleagues in the industry, they have to understand that we are talking about non-linear phenomena. So it does, when you have, let's say, I don't know, a sail, a kite, whatever, this is non-linear. I mean, the fruit number, the speed of the vessel, the loading conditions of the vessel, all of these parameters, they have an impact. So we have to be very careful. I mean, we are not talking about linear, let's say, a phenomena where if you add this, then you get this. If you do this, then you get that. This is, let's say, very naive to understand and to believe. So you have to have, let's say, a holistic approach of the problem: hull, propulsion, and of course performance.
Yeah, and if I could just add to that, I remember a number of meetings a couple of years ago where groups were looking to cluster together fuel saving or energy efficiency measures, and every manufacturer was saying, "Oh, we've saved 3%, or we've saved 2%, we save 5%," and if you put it all together, you'd get 40% saving for the vessel. But the problem, one of the problems, is they're all indicating the first 1 or 2% for each person, so they're claiming the same percentage saving. But also, how does one measure affect another measure? And would you guarantee the savings of another company's product? And that you start getting into a lot of interesting discussions. And I think from a 40% initial focus, I think it boiled down to about a 16% when it was all collated together. So yeah.
And let's say that in some cases, all these assumptions, they violate the second law of thermodynamics, which is one of the usual flaws. I mean, please don't laugh with that. I mean, because you have people who claim, okay, I have a sail moving my ship, then I might use some pumps, some jets, blah, 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 and then I'm going to produce also electricity and have Wilson blows and everything. But guys, it doesn't work like this. I mean, you cannot beat physics. I mean, physics are there.
Correct. A very good point. Yeah, so some nice discussion. Are there any other questions from the audience? I don't see anything.
There's one just come up.
Oh, we do have one in the chat.
I can answer this question.
Yeah.
Yeah, because no, we don't have this reference because we don't have the same fuel price for all ships. So what I can tell you is that we have many times compared the cost of auxiliary engines, let's say the cold ironing, for example, at ports with the average consumption that we have on auxiliaries, but the huge assumption there is the price of the fuel. So it is very difficult, let's say, to compare let's say a source of propulsion like let's say the wind assist technologies with another source of propulsion like a combustion engine without having the cost of the fuel. And please be careful, we need the exact cost of fuel. I don't care about the fuel price at the well, let's say Henry Hub in the US. I would like to have the source and the supply cost that I have when buying fuel for my ships, and this might be, let's say, a huge cost element. So it's very difficult just to have a rule of thumb. How much do you need per megawatt?
Yeah, and I think that there's also the issue, and I'm just reading the rest of Richard's your comment there. Yeah, that we have a wide range of different systems going on to a wide range of different size vessels with a wide range of operational profiles, etc., all giving different amounts of power, all giving different contributions in different situations on different routes. I think the issue here is also that we are still at an early market stage. So that those vessels that are out there, we could be calling those demonstrator vessels. They're all operating commercially, but we don't have the data from all of those vessels. Not every technology company is going to be sharing all their data. Not every shipping company will be sharing all their data. In fact, the go-to stance is not to share fuel data, because that's your competitive advantage. So the WASP project is actually a very interesting way to take a look in behind that issue and actually start to capture this information which the industry needs. So yeah, it's it is a challenge, and it's one of the barriers that we are gradually overcoming, and it will get better, but it will take time. And that's when the maturity of the market kicks in. Yeah. So Orestes, if you wanted to say something to that.
Yes, I mean, Gavin, we work together for more than 5 years right now, and we try also to provide accurate information, because assume that we provide an information like $300 per megawatt. That is, let's say, not a rule of thumb, but it's a usual, let's say, price that you have for other technologies, okay? Then any mistake, any error, any omission, any assumption that is not conveyed properly, then it will not serve the cause and the purpose of promoting wind assist technology. So we have to be very careful with the information that is released and published. And this is also one of the huge benefits, I think, of the WASP project, that out of 5 different, let's say, business cases, then you have, let's say, figures, and you can, let's say, communicate this data.
Yeah. And this will be one point. This will be one point of reference for the industry. So yeah. So Richard, you're going to have to come back in a few months' time when we have a little bit more definitive results from WASP. But there are some other projects that are looking to anonymize and collate data sets that are available, and those are coming online pretty much now. But again, then the accuracy of those, Orestes is absolutely right. The quality and the accuracy of these systems has to be spot on. Otherwise, you're actually causing more problems than you're solving.
Yeah.
Okay. Well, that's, yeah, some good questions and good discussion. And I'm mindful of the time. I have another question. I think I'll ask you two offline though, since we've actually gone a little bit over. As I know where to find both of you easily. So I'll do that after the fact. Thanks again to our speakers, though. This was really a very nice webinar, and I think good to have the combination both of technical and financial, because of course the reality is they are very closely coupled to one another. You can't have one without the other. So again, thanks very much to our speakers. I really appreciate the time, and thanks to all the attendees. And like I say, this presentation, the recording, will be put online on the WASP website in the near future. And if you have questions, you can get a hold of me. My contact details are in the invitation announcement if you need help with how to find the recording. But otherwise, yeah, thanks a lot to all of our participants. And yes, the rest is.
Yeah, could I just?
No, it's Gavin. No, it's Gavin.
Okay,
Gavin
yeah,
first.
Sorry. Yeah, just on the technical front as well. You know, I've given a general overview. If you want more specific information and you're interested in delving in more deeply in this, we do have a research center on our website, which has about 40 or 50 papers listed there, mostly public ones. But there's also going to be a RENA Wind Propulsion Conference. So RENA and IWSA in combination. It was going to be in February. It may be delayed now a little bit. And also there's the Blue Week Conference, which is run by Matt, which will have papers from WASP, but also technical papers from, or technical presentations from projects, etc. So I can send you the details for that, and maybe you could post that on the university notice board as well.
Yeah, definitely. Thanks, Gavin.
No, welcome.
Josh, one last point. I mean, you cannot do financing in this business unless you understand the technical stuff. So I have an engineering background, and unless let's say you understand the technical aspects of this business, it's very difficult, because you're not talking about a very simple product, and there are many discontinuities in our model and in our calculations.
No, absolutely. Yeah, I think engineers in general lose sight of the financials, or just don't have enough background or experience with it, and just tend to say, I'll leave that for someone else. But I think it's becoming more the case that as engineers, we do have to get at least a few more of those tools in our toolboxes, really, to be able to address these problems. So I couldn't agree more. Well, thanks again, guys. Thanks again to all the participants. I will turn off the recording now, and like I say, that'll be put up online on the WASP website. So everyone else have a nice day. Thanks a lot.
You too. Bye-bye.
Thanks very much. Bye-bye.
Bye-bye.